Welcome to OZL 111 Animal University. My name is Professor Emmanuel Kijabe. I'm the Chief Instructor of this course. In this course, we are going to learn about the diversity of animals in general. To begin with, I'll give a general introduction of the course, in which I will introduce you to the great diversity of animals. The course is divided into two parts. In the first part, we'll start about group of animals without a backbone, known as invertebrates. In the second part, we'll learn about animals with a backbone, known as the vertebrates. The material will be covered in 21 lectures. The first 12 lectures will be on the invertebrates. In this part, we'll be able to classify the vertebrates, understand their body plan, the evolutionary relationship, adaptation to the environment, and the ecological and economical importance. In addition, you will study the many groups of animals, which are the protozoa, the parazoa, the radiata, the asolomates, the pseudosolomates, the solomates, and the buclostomes. In the second part, starting from chapter 13, you will be introduced to intermediate phyla, which are neither invertebrates nor vertebrates, the hemichordates. Then in lecture 14, you will start to start the animal with a backbone, the vertebrates, and then classify them. You will start their evolutionary relationship, adaptation to the environment, and the ecological and economic importance. Moreover, you will learn about the origin of vertebrates, study the vertebrates without jaws, fishes, amphibians, reptiles, birds, and mammals. You are encouraged to read textbooks after each lecture and any other relevant textbooks in order to have a more comprehensive understanding of the subject. Practicals for this course will be provided in a separate practical manual. In this course, we have divided the lectures in 6 knowledge areas. Knowledge area number 1 is introduction to invertebrates, animal classification, body plan, and evolution of body cavities. Knowledge area number 2 is about the protozoans, the parazoa, phylum Polyphera, meaning the sponges, the radiata, the asolomates, which belong to the phylum Platyhelminths. Knowledge area number 3, we are going to start the pseudosolomates, which include the phylum Nematoda, phylum Lotifera, phylum Blastocysta, phylum Nematopha, and the phylum Ancothephala. Knowledge area number 4, we are going to start the solomates, phylum Mollusca, phylum Annelida, phylum Arthropoda, and the Dysomia, also which belong to the phylum Echinodermata. Knowledge area number 5, you are going to start the phylum Hemichordata and the phylum Chordata. Here we will go through the introduction of the phylum, Hemichordata and Chordata, learn about the non-vertebrate chordates, vertebrate without jaws, the vertebrates. We are going to classify the chondrichites, the crust osteichitis, and also the bony fishes. In knowledge area number 6, you learn about the amphibians, the reptiles, the apes, and the mammals. Now we are going to learn about the course objectives of this course. By the end of the course, you should be able to describe the diversity of animals, classify the animal kingdom, explain the evolutionary relationship among the various groups of animals, describe the characteristics of the various animals phyla, and explain the economic importance of animals to mankind. Now, let us begin by going through knowledge area number 1, which is introduction to invertebrates. Invertebrates are animals without a backbone. Invertebrates are very diverse and constitute millions of species. They are very diverse in form, ranging in size from 1 to too small to see with naked eyes, to enormous giant animals such as the squids. They are found in almost every habitat in the world. Almost 99% of all animals are invertebrates. By the end of this lecture, you should be able to list the representative of the invertebrates, explain the ecological and economical importance of invertebrates, classify the animal kingdom, describe the body plan and the evolution of body cavities in animals. Now let us learn on the representative of the invertebrates. Let us begin with the protozoa. Protozoa are a diverse assemblage of unicellular organisms with puzzling affinities. They include numerous phyla of varying evolutionary relationships. They are distinct animals, animal-like in several respects. They lack a cell wall. They have at least one mortal stage in the life cycle, and most ingest their food. Throughout their long history, protozoa have radiated to generate a bewildering array of morphological forms within the constituents of a single cell. Thus, in this course, you will study these organisms in a single lecture as convenience and not implying that they form a monophyletic group. Again, we are going to learn about the multicellular organisms. Multicellular organisms, all known as the metazoans, are typically divided into 3 grades. The mesozoa, which constitute a single phyla, the parazoa. This includes the sponges and phylum Placozoa and Eumatozoa. The Eumatozoan comprises all higher animals, or the invertebrates and vertebrates. The Eumatozoans in the invertebrate group are the phylum Cnidaria, which are four classes: Hydrozoa, Cyphozoa, Cubozoa, and Athrozoa. We have the phylum Platyhelminthes with 4 classes: the Tubularia, the Trematodes, the Monogenia, the Cestoda, the common tapeworms. We have phylum Nematoda, the roundworms such as Ascaris and Lombricoides. Phylum Annelida with 3 classes of the Poricita, the Origokita, and the Hibinea. Phylum Mollusca with 7 classes: Polyplacophora, Solengastre, Placophora, Gastroda, Scapopoda, Bivalvia, and Cephalopoda. Phylum Arthropoda with 5 classes: Crustacea, Achinida, Insecta, Theropoda, and Hippopoda. Phylum Heterodermata with classes Crinoidea, Asteroidea, Orphiloidea, Echinoidea, Orthoidea, and Concentricycloidea. After appreciating the diversity of the vertebrates, now let us look into the economical and the ecological importance of the animals. They are involved in waste recycling. In the soil, earthworms and other vertebrates play crucial roles in the decomposition of organic matter. Also, they form a basis of ecosystems. Birds and the fish rely on these vertebrates for food. The abundance and diversity of marine plankton is a useful indicator of healthy marine ecosystems. Do you know about pollination? Many plants rely on insects to pollinate their flowers and so complete their productive cycle. Well-known pollinators include bumblebees, honeybees, butterflies, and hoverflies. Less well-known ones include monkeys, thrips, beetles, and solitary bees. Food chains. Invertebrates form the basis of numerous food chains. Many birds feed on invertebrates, whether as food for their chicks or as part of their adult diet. The chicks of blue ticks eat an estimated 35 billion caterpillars and other small invertebrates every year. Marine whales such as the minke whale and many seabirds feed extensively on krill and other marine crustaceans. Mammals such as bats, badgers, gulls, and shrews also feed on invertebrates. Invertebrates are also used in assessing habitat quality. Insects are used in assessing habitat diversity, habitat fragmentation, and the impact of climate and other environmental change. In addition, there is a long history of invertebrates being used as indicators of the health of the environment. Invertebrates are also used to test the toxicity of chemicals and pesticides. In pest control, pests can be individually targeted with specific invertebrates, enemies like native ladybirds and plastoid wasps. Increasingly, these are available commercially and they may offer an environmental friendly option to chemical control. Above all, invertebrates have medical importance. Arthropods of medical importance include insects, class Insecta, and arachnid, class Arachnida. Of the arachnids, only mice and ticks, order Carina, are vectors of disease. Of the insects, 5 groups have medical importance. True flies, which belong to order Diptera, true bugs, which belong to order Heteroptera or Hemiptera, lice, order Amniplora, and the flies, order Siphanoptera, and cockroaches, order Leptoptera. After appreciating the diversity and the economic and the ecological importance of vertebrates, let us now look at how these animals are classified. In the previous lecture, you have learned that invertebrates are very diverse animals and they comprise about 99% of all animals. Invertebrates are not only animals in numbers, but also present diversity of size, structure, mode of reproduction, models of life, and the ecological and the geographical distribution of the earth. This great diversity of life on Earth today has prompted biologists to categorize similar organisms in order to better understand them and indicate their relationship to other living organisms. This effort gave rise to the science of taxonomy. The early scientists classified things according to size, color, or whether they possessed a soul. Rapid growth of systematics in the 18th century culminated in the work of Carolus Linnaeus, who lived from 1707 to 1778, and he produced our current scheme of classification. In the present lecture, you will learn the science of classification in order to enable you to organize information about organisms and their needs. Now let us look at the principles and methods of classification. Organisms are arranged into ascending series of groups of increasing inclusiveness or hierarchical system of classifications. The major categories or taxa and the singular taxa into which organisms are grouped are given one of the several standard taxonomic ranks to indicate the general inclusiveness of each group. The hierarchy of taxonomic ranks has been expanded considerably since the times of Linnaeus. It now includes 7 mandatory ranks in descending series: the kingdom, the phylum, the class, the order, family, the genus, the species. A taxonomic has options of subdividing these 7 ranks even further to recognize more than 7 taxa. We have superclass, subclass, infraclass, superorder, suborder, and others for any particular group of organisms. For very large and complex groups such as fishes, insects, and some plants, these additional ranks are needed to express different degrees of evolutionary divergence. Nomenclature. Nomenclature is the process of giving a scientific name to an organism once it is identified. Organisms are given common names in different parts of the world, and the same common name may be used for different kinds of organisms. Even within one country, common names can confuse. The cat flea and scent flea, snow flea, and water flea have little in common. Despite sharing part of their common names, each of these organisms is in a different major group. A scientist's name is universally used for a particular species or a particular group of organisms. The formation and use of scientific names of organisms classified as animal are governed by the National Code of Zoologists, Nomenclature, or in short, ICZN. Of those classified as plants, including fungi, are classified by the International Code of Botanical Nomenclature, ICBN. And for those classified as bacteria, including Actinomycetes, by the International Code of Bacterial Nomenclature of Bacteria, ICNB. Binomial nomenclature. The names of species consist of 2 terms and are therefore called binomial or binary. Each species has a Latinized name composed of two words, hence binomial, written in italics, underlined if written or typed. The first word is the name of the genus, written in capital initial letter. The name of the genus is always a noun, and the species epithet is usually an adjective that must agree in gender with the genus. For instance, the scientific name of a common robin is Turdus migratorius. L. Turdus/migratorius for the migratory habitat, for its migratory habit. So you can see that the Turdus, as explained previously, is an adjective that must agree in gender of the genus. And when we look at the name migratorius, it is about the habit of migrating. A species epithet never stands alone. The complete binomial must be used to name a species. Names of genera must refer only to single groups of organisms. A single name cannot be given to two different names. Theories of taxonomy. There are two current popular theories of taxonomy: traditional evolutionary taxonomy and the phylogenetic systematic, or called tradistic taxonomy. Both are based on evolutionary principles. However, they differ on how evolutionary principles are used. The difference have important implications on how we use taxonomy to study evolutionary processes. The relationship between a taxonomic group and a phylogenetic tree cladogram is important for both theories. This relationship can take one or three forms. It can be monophyly, paraphyly, or polyphyly. A taxon is monophyletic if it includes the most recent common ancestors of all members of a group and all descendants of the ancestors. I repeat again. A taxon is monophyletic if it includes the most group and all descendants of the ancestors. Or it includes the most recent common ancestors of all members of a group and all descendants of that ancestor. A taxon is paraphyletic if it includes the most recent common ancestors of all members of a group and some but not all descendants of that ancestor. A taxon is polyphyletic if it does not include the most common ancestor of all members of the group. This situation requires the group to have at least two separate evolutionary origins, usually requiring independent evolution acquisition of a diagnostic feature. For example, if birds and mammals were grouped in taxa called hemiodem, would have a polyphyletic taxon, because birds and mammals descend from two quite separate amniotic lineages that have evolved hemiodem independently. The most recent common ancestors of birds and mammals is not hemiodem and does not occur in polyphyletic homothelia as just described. Both evolutionary and cladistic taxonomy accept this classification. They differ regarding acceptance of paraphyletic groups. Here we have an example of phylogenetic tree of life you can go through it and appreciate how different groups of animals have diverged over time. We have the bacteria, and archaea, the eukaryota, and you can appreciate these divergences among the tree of life. In order to appreciate more about this diagram, you should go to read textbooks and other materials in order to expand your knowledge in this area. Now let us look at the kingdom of life. The AS classification system recognizes only two kingdoms of living things, which are animals and plants. But biologists discovered mechanism and learned more about other organisms. They added kingdoms in recognition of fundamental difference discovered among organisms. Most biologists now use a six-kingdom system of six-kingdom system first proposed by Carl Woese of the University of Illinois. The six kingdoms are as follows. We have kingdom Archaebacteria, prokaryotes that lack a peptidoglycan cell wall, including the methanogens and extreme halophiles and thermophiles bacteria. Kingdom Eubacteria, prokaryotic organisms with a peptidoglycan cell wall, including cyanobacteria, soy bacteria, nitrogen-fixed bacteria, and pathogenic disease-causing bacteria. The third kingdom is the kingdom Protista, eukaryotic, primarily unicellular, although algae are multicellular, photosynthetic or heterotrophic organisms, such as amoebas and paramecium. Kingdom Fungi, also eukaryotic, most multicellular, although yeast are unicellular. Heterotrophic, usual non-motile organisms with cells of chitin such as mushrooms. The fifth kingdom is Kingdom Plantae, eukaryotic, multicellular, non-motile, usually terrestrial, photosynthetic organisms such as trees, grasses, and mosses. And then we have the Kingdom Animalia, which are eukaryotic, multicellular, motile, heterotrophic organisms such as sponges, spiders, newts, penguins, and humans. In this diagram, you can now appreciate the kingdom of life as shown. You have the kingdom of bacteria, which have unicellular organisms, the prokaryotes. You have the Archaebacteria, the unicellular prokaryotes, the Protista, which include the common animals such as protozoa, which are both unicellular and multicellular. And then you have the fungi, cellular, the eukaryotic, plantae, plant kingdom, we know it very well. And then lastly, the kingdom of Animalia, which we know. Now let us look at body plan and the evolution of body cavities. after heavy appreciated the diversity of the animal kingdom, understood how to classify them, and then into their various kingdoms. Then let us look at one of the unique features of the animals, which is the evolution of body cavities. In this lecture, you'll learn how phyla are grouped in terms of body plan, types of symmetry, tissue, organization, and the presence of cell. Every organism has an inherited body plan that may be described in terms of broader inclusive characteristics, such as symmetry, presence or absence of body cavities, presence or absence of segmentation. In the present lecture, you should be able to describe 5 key transitions in the body plan: evolution of tissues, evolution of body symmetry, evolution of body cavity, and evolution of protosomes, the neutrosomes, development, and evolution of body segmentation. So by the end of this lecture, you should be able to describe the importance of symmetry to an animal life, distinguish between radial from bilateral symmetry in animals, classify animals according to body cavities, define the terms assolement, pseudocorrelate, and equivalent, describe the protosomes and the neutrosomes, discuss the evolutional significance of body segmentation. Now let us look at body symmetry. This is the first key transition in the evolution of the animal body plan. The evolution of the body symmetry. Let me repeat again. This is the first key transition in the evolution of the animal body plan. That was the evolution of the body symmetry. One of the criteria used to classify animals is type of symmetry. Asymmetry means that the animal has no particular symmetry. For example, the sponges. When you look at the sponges, they don't have any symmetry. They are not radial, they are not bilateral. So when we say asymmetry, it's animals which lack body symmetry. For instance, the sponges. Radial symmetry means that the animal is organized circularly and just as a wheel. It is in form two identical halves. Two identical halves are obtained no matter how the animal is sliced into them. We are going to see examples of body symmetry in the slides below. They have a body design in which the parts of the body are arranged around a central axis in such a way that any plane passing through the central axis divides the organism into two halves. There are approximate mirror images. For example, phyla, jellyfishes, sea animals, and corals, and xenopharia, called jellies. Radial symmetry animals tend to be attached to a substrate that the accessory. Imagine an animal with a radial symmetry body plan. It means that it doesn't have specific models. So most of animals are found attached to a substrate and the accessory. These types of symmetry is useful to these animals since it allows them to reach out in all directions from one center. They cannot go in one direction only. They just move around because they don't have legs to go forward or backwards. They just move around on the environment. So this is very useful for those animals who are sessile, sedentary animals who are attached to a substrate. For instance, those animals which take the sea floor. So, this diagram shows a sea star, a typical example of a radial symmetry body plan. For those who reside near the coastal areas, are very familiar with this animal. You can appreciate that its shape is round and it is attached on the substrate. So its movement can just move around at its fixed place. So this is a typical example of a radial symmetry body plan. Now let us look at the bilateral symmetry. Means the animals has definite right and left halves that are mirror image of each other. Meaning that if you cut animal in a half, you will get similar two equal parts, which are mirror image to each other. One longitudinal cut down the center of the animal will produce two equal halves. A bilateral symmetry body plan has a top and a bottom, unlike the radial, which you cannot identify the top of the bottom. But this has a top and bottom. Better known respectively as the dorsal and the ventral portion of the body. We are going to appreciate this body plan again later at the following slides. It also has a front and or anterior end and a back or posterior end. Bilateral symmetry constitutes a major evolutionary advance. This unique form of organization allows parts of the body to evolve in different ways, permitting different organs to be located in different parts of the body. Let me repeat this. This unique form of organization allows part of the body to evolve in different ways, permitting different organs to be located in different parts of the body. Bilateral symmetric animals tend to be active and to move forward and anterior at the anterior end. They are therefore efficient in seeking food, mates, and avoiding predators. These diagrams represent typical examples of a radial and a bilateral symmetry. So you can differentiate between a radial and a bilateral symmetric animals. In this picture, you can see that this is a cylindrical, which is a radial symmetry. You can just divide it. It is radial and symmetry. But when you divide it in between, you cannot get the mirror image of each other. But in this insect, you can see that when it has a posterior end, it is an anterior end and a posterior end. And you can dissect it in area half and get the mirror image of each other. But when you look at this, you can't tell where the posterior end is and where the dorsal end is. And also can imagine the movements of these animals forward or backwards. It's not very difficult. Therefore, even when it is involved in activities of searching for food, it experiences some problem because its movements are limited. But this one, the movements are very, very clear specified, and they keep that they are very successful in on Earth. Examples of bilateral symmetry include all higher animals starting from the insects up to man. Now let us see the second key transition in the evolution of animals. We have seen that the first important key transition in evolution was the formation of the body symbol. And now let us see the second key transition in the evolution of animals, body part, or the evolution of the body cavity. The evolution of efficient organ system within the animal body depends critically upon a body cavity for supporting organs, distributing materials, and in fostering complex developmental interactions. The presence of a body cavity allows the expansion and sometimes lengthening portions of the digestive tract. This longer passage allows for storage of undigested food, longer exposure to enzymes for complete digestion, and even storage and final processing of food remnants. Such an arrangement allows animals to eat a great deal when it is safe to do so, and then to hide during the digestive process, thus limiting animals' exposure to predators. An internal body cavity also provides space within which the gonads, ovaries, and testes can expand, allowing the accumulation of large numbers of eggs and sperm. So you can see how this body cavity are very important to the life of animals. Such accumulation helps to make possible all the diverse modification of breeding strategies that characterize the more advanced phyla of animals. Furthermore, large numbers of gametes can be released when the conditions are favorable. It's possible for the survival of the young animals. In this regard, 3 kinds of body cavities are found in the bilateral symmetric animals. Solomates have no body cavity. So let's look at the types of body cavity. We have the astromates, which have no body cavity at all, and these include all lower animals. We have the pseudo-solomates. Pseudo meaning false. These have a false body cavity called the pseudocell, false body cavity located between the mesoderm and the endoderm. And now we then have the solomates, in which the fluid body cavity develop within the mesoderm and may be formed by 2 methods: basicocellus splitting the mesoderm or enterocellus from pouches of the gut. These coelomates, or in other words, the true coelom, the true body cavity, are all higher animals. In coelomate animals, the gut is suspended along with other organs of animals within the coelom, which is called the true body cavity. The coelom is surrounded by a layer of epithelia. cells entirely derived from the mesoderm. The portion of the epithelium that lines the outer wall of the cilium is called the peritoneum. And the portion that covers the internal organs suspended within the cavity is called the visceroperitoneum. Again, let us now appreciate the types of body cavities and examples. For those animals which have no body cavities at all, which I say belong to lower animals, including the flatworms, you can see that there is no distinct body cavity. You can see there is a body covering from the ectoderm, tissue-filled region from mesoderm, and there's a tract from endoderm, but no specific cavity. And then you have the solvent, the true body cavity animals, belong animals starting from the annelids, as indicated in the diagram here. You have the body covering from ectoderm, true tissue-filled regions from mesoderm, digest tract from endoderm, and the cavity in white, the white color here. And for those which have false body cavity, it mainly belong to the phylum Nematoda, such as ascaris, you see here from the diagram. These have a bundle covering also from ectoderm, and tissue-filled region from mesoderm, digest tract from endoderm, and a false body cavity, not a true body cavity. We have learned that we have learned about the two key transitions in the evolution of animals, which are very important in classification of animals. Now let us learn about the third key transition in molecular plan, which involves the subdivision of the body plan into segments. Body segmentation. During the animal cell development, these segments become most obvious in the mesoderm, but later are reflected into the endoderm as well. Two advantages result from early embryonic segmentation. In annelids and other high segmented animals, each segment may grow to develop a more or less complete set of adult organ system. So each segment can go to develop a more or less complete set of adult organ system in annelids. Locomotion is far more effective than when individual segments can move independently, because animal as a whole has more flexibility of movements. Imagine you are just in one segment, which your movement is very rigid. But if your body is divided into segments, then there is a flexibility of movements. Also, we are going to look later that those segments also functions as presses for attaching legs, which can assist more efficient movement and other activities in the environment. Segmentation underlines the organization of all advanced animals. In some adult animals, the segments are fused, but segmentation is usually apparent in the embryonic development. So you can see that segmentation underlies the organization of all advanced animals, meaning animals. We need these segments because most of our body is divided into segments where the body plan provides space for different types of organs and other body functions. In vertebrates, the backbone and most muscular areas are segmented. In addition to segmentation, leads to specialization of parts because the various segments can become differentiated for specific purposes. I need to explain this again. Segments form specialization of parts because in some segments you have specializations of for different purposes. For instance, let us take an example. Ourselves, we have the head, we have the chest, we have the abdomen, things like that. Thank you very much for listening. This makes the end of this area 1, knowledge area 1. And in this lecture, we have learned about the diversity of animals. We introduce the animal kingdom. We learned how to classify animals, and then we looked into the 3 key areas in the evolution which made life possible for different organisms. Meaning, we looked at the evolution of the body symmetry, we looked at the evolution of body cavities, and then body segmentation. Thank you very much for listening.